Alright class, today we're going to continue our discussion of composite functions and more importantly focus on the domain of composite functions. Now let's say we have two functions f and g, and what we talked about last time was that the inside function g is what we work with first. Oops. And then the outside function f is what we work with second and last. And so let's say we have any function, let's call it f of x, and we have any function, let's call it g of x. And I want to compose these functions by plugging in g into f. Well, if you remember, we have the case, we start with the input, x, and we want to plug it into a function to get out a value. Well, what function can I plug x into? Well, the inside function, which is g. So when I plug x into g, I'm going to get out some number. And it's that number that I'm going to use to plug into a separate function. And what's to get out an answer? So the second function I plug it into is the f function. And I plug whatever was in this box, I plug it into f and get out an answer. And there I have my answer for the output of f of g of x. Now what kind of numbers can I plug into this function? Well, that's what we're going to be answering with this video. First and foremost, let's take a look at the original functions f and g. And we're going to take a look at g first. It's because g is what we plug this function into. What kind of values can I plug into g? Well, I can plug any number into g except the number that makes the denominator 0. So what number makes the denominator 0? 4. So in other words, I can plug 5 into g and get an answer out, and that'll be fine. I can plug 6 in. I can plug any number, but if I plug in 4, I'm going to get an error. So I, in my domain of g of x, can be any number but 4. So as long as I don't plug 4 into g of x, then I'm good. So I'm going to remove 4 out the picture. So I can plug any number into g of x and be able to get, as long as it's not 4, and get out an answer. So let's say I plug in 1. Let's say I plug in 0. Plug in 0 into g of x, and what does plugging in 0 do? It replaces 0 in the function. So when I replace x with 0, I get 2 over 0 minus negative 4. So my actual answer, when I plug in 0 into the function, is the number 2 over negative 4, which is negative a half. Okay? So when I plug in 0 into my function for x, when I plug it into g, I'm going to get out negative a half. So the negative a half is the number that I'm going to actually plug into f. But what does f do? F takes whatever the input is and it takes the square root of it. But when I try and take the square root of negative 1/2, I get an error. Why do I get an error? That's because the domain of x is actually any number that does not give me a negative square root. So the only values that can go into the domain of x are the values that don't give me a negative square root. So I can do 6 and I can do 5. Oops, that's what I want. I can do 5 and I can even do 4.05. But if I do any negative number like negative a half, it's going to give me a problem. So in my domain of f, it can be any number except the negative numbers. So let me try a number that's not 4 and that's not a negative number, and let's see what I get. So let me try 2. 2 will be able to be submitted into the function f. 2 can be able to be submitted into the function g of x. So let's submit 2 into it. When I plug 2 into the function g of x, I get 2 over 2 minus 4, and I still get negative a half. All right. So I cannot even plug in 0. Oh, I'm sorry, I don't get negative a half. it's late, I get -1. But wait, I can't plug -1 into F, because if I plug -1 into F, I'll get an error because F doesn't accept -1s. In fact, I can't plug any number that's negative into into F. Well, what does that mean? That means I have to make sure that all the numbers that I plug into F are not negative. Well, in order to make sure that all the numbers that I plug in to G are not negative, I need to make sure that G never gives me a negative number. I already know G cannot give me X when X is -4, but what makes G a function that gives me a negative number? Well, the numerator is not. It is a positive number, so that doesn't cause G to be negative. And the denominator isn't always going to be a negative number. When is the denominator going to be a negative number? That's an excellent question. Well, let's see. When will X minus 4 be less than 0? Well, if I do simple algebraic manipulation and add 4 to both sides, I get that X minus 4 is going to be less than 0 for any X that's bigger than 4. And that's when we have a problem. I'm sorry, I wrote the symbol wrong. It's not any X that's bigger than 4. It's any X that's less than 4. So any number, not only just 4, which is a no-no, but also any number like 2, which is less than 4, any number like 3, which is less than 4, and any other negative number cannot be used into X, because if I put them as X, it's going to give me out a negative G, and I can't have a negative G because the negative G is going to be put into F, and F can't take negative numbers. So the way I would describe the actual domain, or the type of numbers that I can put into the function G that will allow me to put in values that I can put into F, are going to have to be any number X that's not less than 4. So in other words, any X that's greater than 4 will work. Because any number that's greater than 4, when I plug it into G, I'm going to get out a positive number. And when I get out that positive number, I'll be able to plug it into F, which will always give me an answer. So that's how you find the domain of composite functions. So in order to find the domain of composite functions, you first must find and eliminate those values that cannot go into the outside function. And then you also have to eliminate those values that cannot go into the input function. But not only eliminate the values that can't be inputted into the input function, like 4, but we also have to eliminate those values that when I put them into the inside function, it's going to give me a number output that I can't put into the F function. So I know that's confusing, but with much practice, you'll be able to get the hang of it. So there you go.